10.7c, quadratic formula, missing terms. If a term is missing, we use 0 in the quadratic formula. Let's take a look at example 1. Notice that it is set equal to 0. It has a leading term that is to the second power. So we could write it as 3x squared plus 0x minus 51 equals 0. Notice this hasn't changed the equation at all. We've just substituted in something equal to 0 as a placeholder so we can continue to use the quadratic formula. A is equal to 3, B is equal to 0, and C is equal to negative 51. Moving on, we can use the quadratic formula for our equation, and we get x is equal to negative 0 plus or minus the square root of b squared, or 0 squared, minus 4 times 3 times negative 51. All over 2 times 3. We can simplify this substantially because of the zeros. We don't need to worry about negative 0. That's just 0. And we can rewrite the plus and minus sign in front of the radical. Then we're going to have negative 4 times 3 times negative 51 all over 6. A negative times a negative right here gives me a positive. Four times 3 is 12, times 51 is 612, which is not a perfect square over 6. I should note at this point that before we move from this here to this here, we have to remember that we can reduce this and this. The reason we can do that is if we take this 4 outside the radical, it would be plus or minus 2. So let's put a 2 out front. So we're going to have x is equal to plus or minus 2 root 3 times 51. All over 6. Notice that 6 is the same as 2 times 3, so there is a common factor of 2 that we can reduce out. Now it's reduced. 153, you're not going to get anything out of there. 153 is not a perfect square. It doesn't have a factor that we can pull out that would be common to 3, and so we've reduced it. So our final answer is x equal to plus or minus square root of 153 over 3. And that's your final answer. Let's look at example 2. We've got x squared is equal to 2x. We need to set it equal to 0 because it's not currently set equal to 0. By subtracting 2x from both sides, we get 5x squared minus 2x plus 0 is equal to 0. The reason I put the 0 there is because if we don't put it there, there's nothing for a placeholder. So when we're trying to find a, b, and c, it's pretty easy to find what a and b are, but c is not unless we put that 0 placeholder there. Plugging in the values for a, b, and c into the quadratic formula, we get 2 plus or minus the square root of negative 2 squared minus 4 times 5 times 0. all over 2 times 5. Notice that I put parentheses around that -2, so when I square it, it's actually becoming a positive number. So simplifying, I get 2 plus or minus the square root of 4, and we're going to subtract 4 times 5 times 0. 4 times 5 is 20, times 0 is 0. So notice that doesn't help us at all. We're just going to leave it as a 4 because 0 times anything is 0, and that's all over 10. 4 is a perfect square, so we can rewrite this as 2 plus or minus 2 over 10. So we will indeed have two solutions once again because of that plus or minus sign right here. We end up with x is equal to 2 plus 2 over 10 and 2 minus 2 over 10. Let's take a look at what those reduce to. We get 4 over 10 on this one, and we get 0 over 10 on that one. This one will reduce if we divide both the numerator and the denominator by 2. So our final fraction is 2/5. We can't have a 0 in the denominator. That would make that undefined, but zeros in the numerator are okay. 0 divided by any number is 0. So x is equal to 2/5 and x is equal to 0.